Hello everyone, I'm Elena Pastor from Politecnico di Torino, Italy. I'm going to present our work explaining speech classification model via word-level audio segment and paralinguistic features. The title pretty much says what our work does, but let's start in order with the context and with the motivations. Nowadays, speech classification models are applied in various tasks, often in an end-to-end manner where the audio signal is directly processed to perform the classification without the need to first transcribe and then process the text. One application is the one here reported, which is the task of intent classification when we interact with a virtual assistant. For example, we ask them to turn up the bedroom heat, and these models process the audio signals and can label our data to then perform some task. So, for example, the assistant predicts that the label of the slot action is increase, the location is bedroom, and the object is it. Okay, so we have the prediction, but we can ask ourselves, okay, but why? First, why do we care to know why? On the one hand, because we want to know if these models are right for the right reasons. So, for example, if we say turn up the bedroom heat, we would like that the model to rely on turn up for the prediction of the increase action. Then all the models make mistakes, and so we want to know why they are incorrect. And also because we want to understand if the model encodes some biases. For example, we may want to uncover if some characteristics of the speaker, such as the pitch, such as the speaking rate, have a strong impact on the predictions. So we said that we want to explain the prediction, but let's better clarify our goal. We have our audio data and we have our label, and we want to explain which is the interaction between the utterance components and the predictions in a human understandable manner. So our goal is for the explanation to be interpretable for us as humans. And this brings us to our first research question, that is, how do we define interpretable representations describing the utterances? So which are the components of the speech audio that we care about? So on one hand, we have the semantic. We want to understand which is the impact of the spoken words on the predictions. But speech data is not just the semantic. We also have a set of paralinguistic information that composes the utterances, such as the prosody, has the pitch and the speaking rate of the speaker, or external conditions such as the noise level. So we want to understand which is the impact of these two components, the semantic and the paralinguistic, on the output. So this is also our second question. So how can we explain the predictions at these two levels? We answer this question by proposing a perturbation-based approach. We follow a major research line in explainable AI, that is explaining by removing or explaining by perturbing. And we adapt this idea to our context for speech data. At a high level, the process consists of perturbing the signals with respect to an individual feature, be it the spoken words or a paralinguistic features, and we then measure the impact on predictions. And the idea is that the higher is the change, the more the models relies on this feature. So let's see the approach more in details, and let's focus first on one of the components, the semantic. So we have our utterance. In this case, we have that the model predicts the action as increase with 98% of confidence or probability, and the location as bedroom with 85%. And we want to understand which are the spoken words that impact the prediction. As a first step, we use a word-level time alignment model to derive the word-level audio segment, so that we have the beginning and the end of each word and the transcription. The second step is perturbing it. And we perturb word-level audio segment by masking audio segment and specifically by zeroing them. In this case, we note that by masking the word up, the probability dropped from 98% to 25% for the increased class. We repeat this process for multiple audio segments, also considering multiple perturbation at a time, depending on the explanation method that we want to adopt. And for each of them, we observe the impact on the prediction. Finally, we aggregate the feature impact, and in our work we use two ways, and so we propose two explanation methods. One of them is based on the leave one out technique. As the name says, we perturb it just one element at a time, and we observe the impact on the prediction probability, and this is the importance. The other approach uses Lime explanation method that is able to take into account which is the interaction of one or more segment and to aggregate it. So as a result, for both techniques, we obtain a relevance for each spoken word and for each label. So considering this case, we obtain that up is the most relevant term for the increase class, while bedroom is the word that impacts the bedroom prediction. This is reasonable and it is aligned with what we expect, and this we'll see is a characteristics that we want to analyze. From the paralinguistic aspects, we consider one paralinguistic feature at a time. So suppose that we want to consider the speaking rate. We perturb the signals based on this interpretable feature. In this case, for the speaking rate, we just stretch the audio. So we perform a time stretching operation, and so we shrink it or we enlarge it. As before, we do this operation multiple times and we observe the impact on the prediction. And finally, we aggregate the impact. In this case, we observe a prediction change, and so the models relies on the speaking rate characteristics for the prediction. Our speech explainer is available on GitHub, so I invite you to try it. With that, I thank you all for the attention. Here there are my contacts, so reach me if you have any curiosity on our work, and thank you again.